So in terms of your nucleophilic sub, there are two mechanisms, SN1, SN2. So let me explain the word or the number first, the 2 and the 1. Why is there a 2? Why is there a 1 here? That is the meaning. The word 2 represents 2 molecules. But what 2 molecules? 2 molecules involved in the slow step. There are some steps slow, there are some steps fast. So this is 2 molecules involved in the slow step. So in the slow step here, typically, how do we find it? You find it in the first step. So that means the first step is 99.9% is a slow step. Not always, but it's about 99.9%. Now let me use SN2. Focus on the number, forget about the alphabet SN, just focus on the word 2. How many molecules you see on the first step? 1, 2. Oh, that's why it's 2 here. That's the meaning. Right? Very simple and straightforward. Now, how about 1? We can figure it out. 1 means 1 molecule in the slow step. And normally it's the first step. Can we take a look at SN1? SN1, the 1 here, the 1 is 1 molecule in the first step. So now we understand the word 1, we understand the word 2. Then how about the word SN? What does SN mean? S represents the word substitution. This is how it means. S represents substitution. The substitution is taken place by a nucleophile. That's why the word N is there. So it is a substitution taken place by a nucleophile, which involves 1 reactant in the first step. It's a very deep meaning, right? Okay, so this is how they come up with the name. Substitution, nucleophile, and involve 1 molecule in the first step. Now, if you appreciate the name by itself, this will give you a lot of idea what's going on. Okay, but please don't robotic, just remember the name like that. Okay, appreciate the name. Later, you will see there's a lot of meaning behind it. Now, I'm going to dive into the mechanism. Can we take a look at SN2 at the beginning so that we understand SN2 first? So in SN2, substitution involving with a nucleophile involving 2 reactants. So there are 2 reactants here. Now let's take a look. Nucleophile performing the reaction. Nucleophile is electron rich. Carbon bonded to the halogen. Halogen is electron negative. So therefore it's delta negative. Carbon is delta positive. This is electrophile. Remember, electron move like what? Move like diffusion. It moves from a region of high concentration to a region of low concentration of electron. High to low. Now, the minute it attacks, what do you notice here? The CX bond break. Why? Now, I want you to think of an analogy like running a 400-meter relay race. You know how a 400-meter relay race look like, right? So a person run the first round. After they run finish, what do? They pass the baton to the next guy, and the guy run and continue with the race. This is the same thing. This is the first guy running the first round. It completed the first 400-meter relay race. It passed the baton to the second guy. The second guy must do? Leave. Don't stay here. So electron pass to the carbon, this bond will break like a 400-meter relay race. And the bond break. Now, the minute the bond break, you will form what we call a transition state. Now, what is the meaning of transition state? Transition state, I like to call it as a fantasized state. What does it mean? That means a state that doesn't exist. It's an imaginary state. I give you an example. If one day, right, somebody from BTS call you, hey, can I have a dinner with you? You know this is not going to be happen now. This is called a fantasized state. A state that doesn't exist. This is called fantasized. This is imaginary. And if you take a look carefully, it will make sense. Carbon can only form 4 bonds. How many bonds you see here? 1, 2, 3, 4, 5. It's not possible. So remember, this is called an imaginary state, a state that doesn't exist at all. It is just a proposed state. Now, what are they trying to do here? They are trying to describe the slow motion process as the bond is broken. So let me show you what I mean. Remember, the nucleophile is incoming, to the carbon. So this is called partial forming the bond. You can think like the 400-meter relay race again. As a person pass the baton to the other person, it's like the process of passing the baton. And the person is ready to run away. So this is partial breaking the bond. So this is like explaining the in-between process, partial forming, partial breaking bond. Now, eventually what happened? Well, the CX bond leave. The minute it leave, therefore the nucleophile is substituted. Now, I want you to pay attention to the very small difference here. The X initially is on the right. The nucleophile is on the left right now. Now, this is a very big deal in organic chemistry because you change from the right direction to the left direction. It's as good as after you finish running a 400-meter relay race, you change from the right-hander to a left-hander. You think it's a big deal? Of course, it's a big deal. This is what exactly happening in SN2 reaction. And this process is what we call inversion of stereochemistry. That means you change the position from the right to the left directly.